Good morning, everybody. We hope you had a very nice weekend. All right, so here's where we got to start. We're finished kind of learning the basics about functions, and the first function we're going to examine in detail is quadratics. In general, a quadratic is f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers. Before we take a deeper dive into this function, we need to review factoring, simplifying radicals, and introduce you to imaginary numbers. Let's start with factoring. When factoring a quadratic, the very first thing you should always look for is a GCF, a greatest common factor. Example, we want to factor 3x squared plus 6x. Do they have anything in common? That's what we're looking for. A couple of ways to find the GCF. I would expect you guys are pretty good at this, but I'm going to write them out anyway. To find the GCF, we write each term as a product of its factors, right? So 3x squared, this piece here, can be written as 3 times x times x. Let me go to red. And 6x can be written as 2 times 3 times x. What do these two expressions have in common? Well, they have a 3x in common, right? So we're going to pull out that 3x all by itself. 3x and 3x. What does that leave over here? That leaves just that x. And over here, that leaves the 2. Now we have a common factor, that 3x. So we're going to take that out. It's like we're factoring the long way. So they have 3x in common. So it comes outside the parentheses. And what goes inside the parentheses is this x plus 2. So factored 3x squared plus 6x equals 3x parentheses x plus 2. Or this is the way most of you, I think, will see it. You're going to know that each of these terms has 3x in common, right? It's not always easy to see. That's why I showed you the other way. So you're going to divide both sides by 3x. 3x goes away. X squared divided by x is just x. 6x divided by 3x is just 2. That 3x that we divided by is outside. The x plus 2 is inside. We still get the same answer. So what happens when we have a longer quadratic? Ax squared plus bx plus c, where a equals 1. A, that's this number over here. That's our leading coefficient. That's what it's called. So when the leading coefficient is 1, we're going to find two factors whose sum is b, the number in front of x, and whose product is c, the number by itself on the end. So we need a sum of b and a product of c. Factor x squared plus 5x plus 6. So we need all the factors of c. That goes in our first column. The easiest way to do this is to write a little table like this. Right? So these are all the factors. You're going to list all the factors you can of 6. There's not many. 1 and 6, 2 and 3. Actually, -1 and -6 would work, but we know we're looking for a positive sum, so we don't have to worry about the negatives. So we found the two that worked, right? 2 times 3 is 6, 2 plus 3 is 5. This is what we're looking for as the sum. Our sum here was 5. That's B, right? This is our B on this side, and this is our C. 2, 3, 2 times 3 is 6, 2 plus 3 is 5. We know we have to have an x and an x because it's x squared, and we're just going to take these two numbers we found, x plus 2, parentheses, x plus 3. This is now completely factored. You can always check by foiling out to make sure you get the right answer. That's a good way to check. X times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. 3x plus 2x is the 5x. 2 times 3 is 6, so we did it correctly. Let's try another one. This time we have a negative number in the middle. So it's going to be a little bit different. We need a sum that adds up to -8, right? That's what we're looking for here. My writing on here is horrible, but that's okay. And we need all the factors of 12, the numbers that multiply to be positive 12. Well, we've got 1 and 12. 1 plus 12 is 13. -1 and -12. Now we know we're looking for a negative number here, so we should look at the negatives as well. -1 plus -12 is -13. That's not -8. Just work your way down the numbers. I did 1, 2, and 6. 2 times 6 is 12. 2 plus 6 is 8. Well, we need -8. -2 times -6, well, that gives us our positive 12. -2 plus -6 gives us our -8. This is the pair that we need. Again, we have squared here. X goes first. Just put these two numbers next to the x minus 2 times x minus 6. That is the factored form of x squared minus 8x plus 12. Let's try a third one. Now the negative is on the end. Right? First we had two positives. Now we have a negative on the end. The last number is negative. How does that change things? Well, we need the factors of -15. In order to be -15, one number has to be positive, one number has to be negative. I could have listed more factors here, but right after the second one, I found my answer. Right? I need my sum to be positive 14, and I need my product to be -15. All right, so 1 times -15 is -15, but 1 plus -15 is -14. That doesn't work. I need positive 14. Switch the signs around. -1 times 15 is -15. -1 plus 15 is 14. This is the pair that we need. And again, because this was a leading coefficient of 1, we just put an x and an x. -1 plus 15, you can check by foiling out to make sure you got it right. Now, what happens when a is not equal to 1? When the leading coefficient is some other number? Well, we can do this. It's sort of called by grouping, but it's really the same process that we just did, except now our factors, our product is going to be a times c, right? The sum is still that same number in the middle, but our product changes to a times c. 6 times -3 is -18. So I need the factors of -18, and I need the sum to still be 7. I still need those to add up to 7. So what are the factors of -18? 1 and -18. Add those together, I get -17. -1 and 18. Okay, I get positive 17. That's no good. 2 and -9 gives me -7, but -2 and 9 gives me 7. So once I find it, you can stop. We could have went on, right? 3 and -6, -3 and 6, but those don't work. Once you find one that works, you can stop. You don't have to write them all out. So we're going to rewrite this so that that middle term, that 7x, is now a sum of these two factors, right? Just like we did here. So instead of writing 6x squared plus 7x minus 3, I wrote it right, I'm going to take that 7x and break it up into these two factors that we just found. -2x plus 9x is 7x. So instead of writing it out with the 7x, I'm going to take those two factors I found and put them in the middle. Now I'm going to group those two expressions together. All I'm doing is putting a parentheses around here, and around here, around here, and around here. Right? That's what this expression is. I'm going to group those together. It's still plus. Now I take out the GCF. What GCF is? 6x squared minus 2x is 2x. That leaves 3x minus 1. Here's a little hint. If we're doing this way, this expression has to match this one. If it doesn't, you did something incorrectly. What is the GCF here? 3. There's our 3. 9x divided by 3 is 3x. Negative 3 divided by 3 is negative 1. I get the same expression here and here, which is what I want. That's one of our two expressions, one of our factors. The other one are the two numbers that are outside. Right? 2x plus 3. That becomes our second factor. And that's our factoring of 6x squared minus 2x. 6x squared minus 2x. 6x squared plus 7x minus 3 factors into 2x plus 3, 3x minus 1. Please check. If we FOIL this out, what do we get? Let's just do this one so you know that it's correct. 2x times 3x is, I'm going to try writing with my finger. Don't know if it's going to work. 2x times 3x is 6x squared. Right? 2x times negative 1 is minus 2x. 3 times 3x is plus 9x. Does that look familiar? 3 times negative 1 is negative 3. 6x squared. Negative 2x plus 9x is plus 7x minus 3. And we get back to exactly what we started with, which was the point. It's just a check of your work. There are some special factors. Difference of two perfect squares. If we have a quadratic in the form ax squared minus c, there's no x term. It's just something times x squared minus a constant. And both a and c, both of these numbers, are perfect squares. Then the factors are the square root of ax squared plus the square root of c times the square root of ax squared minus the square root of c. You know what they are. I know you've seen this. This is just a little more technical on how to get there, right? So here's an easy one. X squared minus 4. X squared, anything squared is a perfect square because the square root of something squared is just that number. 4 is a perfect square. Difference means subtract. We have subtraction. So x squared minus 4 is the square root of x squared plus the square root of 4 times the square root of x squared minus the square root of 4. The square root of x squared is x. The square root of 4 is 2. So we get x plus 2, x minus 2. Again, if you FOIL this out, you will get x squared minus 4. So here's one where we have a number, an a, in front of x squared. But this is a perfect square again. This is that same as that 4 is up there. X squared is a perfect square, so this whole expression is a perfect square. 9 is a perfect square. Perfect square, I know I've been using that term, it's just a number that when you take its square root, you get an answer, not some kind of decimal. So the square root of 4x squared plus the square root of 9 times the square root of 4x squared minus the square root of 9. The square root of 4x squared is the square root of 4 times the square root of x squared, which is 2x. Square root of 9 is 3. We get 2x plus 3, 2x minus 3. And after that, I have sent this as a separate attachment. It's on here as well. These are the ones I want you to do. What I want you to do is all of these on separate paper, do all the work, submit the work through Google Classroom, but on Delta Math, I have added all of these questions with just a place to answer. There's nowhere to show the work on Delta Math. Please just enter your answers. It'll give you instant feedback on whether you got it right or wrong. And tomorrow, if you have any questions, I will ask them. Have a great day, and we'll talk again tomorrow. What's tomorrow? Wednesday? Not sure. That might be our virtual day, but we'll see. All right, guys.